So our lesson this morning is all about colors of light. So we are in the module 5 or week 5. So the most essential learning competency is to explain the hierarchy of colors in relation to the energy of visible light or light. So based on the MELC or most essential learning competency, if we're going to unpack that and come up with the objectives, these are the objectives. First, demonstrate the existence of color components of visible light or light using prism. Then second objective is to explain the hierarchy of colors in relation to energy. And then third, explain that red is the least bent color and violet is the most bent color according to their wavelength and frequencies. So at the end of the discussion, we are expected to answer the following questions. So first, what is light? Second, what are the properties of light? Third, what are the characteristics of light? Then fourth, explain the hierarchy of colors in relation to energy. And then fifth, explain the red bent least and violet bent most according to the wavelength and frequencies. Okay, so when we say light, this is an electromagnetic wave. So it's a wave. Particularly what type of wave? Transverse wave. So this electromagnetic wave is located between the spectrum of infrared and ultraviolet. The other name for light is visible light. Other book, white light. But actually they are the same. This is what we call as the electromagnetic spectrum. In the right side, this is a figure of electromagnetic spectrum, and we have the different radiations according to the arrangement is according to the amount of wavelength and frequencies. So in grade 7, I think your teachers discuss about the gamma rays, the X-rays, the ultraviolet, infrared, and microwaves. So where is the light? Where is the visible light? Where is the white light located? This is located between ultraviolet and infrared. So member siya ng electromagnetic spectrum radiations, but this is located between ultraviolet and infrared. Okay, so light carries energy. So since it carries an energy, it acts in a form of wave. So how does electromagnetic wave looks like? So ito, ganito. Okay? So transverse wave siya, but three-dimensional siya. Kasi this acts in two dimension. We have yung up and down na wave. This is the electric field. And then yung left and right na movement nito na wave, this is the magnetic. So a combination of electric and magnetic. That is why it is called as electromagnetic wave. But what type of wave? It's a transverse wave. So a narrow beam of light traveling in a straight line is what we call as the light ray. And the source of light gives off light in all directions. So what are the characteristics of light? So light does not need a medium in order to propagate. So unlike sound cannot travel without a medium, but light can travel. No need to have a medium. Without medium or with medium, still light can travel. So no need to have a medium in order for the light to travel because they can travel with or without a medium. So even in a vacuum, the light can travel in a vacuum. And take note that if light travels in a vacuum, meaning without any medium, without air, without anything, the light travels fastest. So The light travels so fast and it is in its maximum speed when it travels inside a vacuum with a speed of 3 times 10 to the power of 8 meter per second, or this is also called as 300 million meter per second. That's the speed. That's the maximum speed of light. Okay, and take note, the speed of light decreases as it moves from one media to another. So pag mag-change siya ng medium, there's a tendency that the speed of light will change, will bend. So aside from bending, the tendency is it will always decrease. Okay? So its speed will decrease as it moves along a different media. So this is what we call as the bending of light or refraction. This is one example of the properties of light. Okay, take note that when this light, white light or visible light, passes through a prism, the tendency is the color components will separate, will disperse. And this is what we call as dispersion. But actually, the result of the dispersion is caused by the refraction. And once the colors of white light are dispersed, the arrangement from top to bottom is Roy G. Biv. R stands for red, O stands for orange, Y stands for yellow, G for green, B for blue, I for indigo, and V for violet. So the acronym is ROYGBIV. Roy G. Biv. Take note of that. From top to bottom. So top should be red and the bottom should be the violet. So bakit usually hindi ginasali ang color na indigo? Kasi hindi masyado ito visible sa eye ng human. So usually diretso na from blue to violet. But the correct arrangement is Roy G. Biv. Okay. So try to look at this spectrum. So let us see, this is the red. This side is red and the other side is purple or violet. So as you can see in the red side, the wavelength is more longer compared to the purple side. So meaning the red color has a longer wavelength and the purple or violet has the shortest wavelength. So when we say wavelength, this is the distance from one crest to another crest. So medyo mataas ang iyahang wavelength compared to purple or violet. So we can say that color red has longest wavelength and the color violet is the shortest wavelength. So all waves have wavelength and frequencies. So we said that wavelength is the distance from crest to crest. And how about frequencies? The number of crests passing through in a 1 second. So here we can say that in color red, frequencies are lesser compared to the violet. There are more crests found in the violet. This is because violet has a shortest wavelength. Okay, so therefore we can say that the longer wavelength, the color that has a longer wavelength will have a lesser frequencies. Whereas the color with shortest wavelength, we can say that more frequencies in color violet. If I will ask you, Which color has a greater wavelength? The orange or yellow? What's the answer for that? Greater,
Orange po.
longest wavelength. Very good. Okay? Kasi medyo mas malapit siya dito sa red. Okay? How about between green and blue? Which was had shortest wavelength?
Blue.
Yes. Kasi dito na side shortest. So meaning the wavelength is decreasing from red color going to violet. So take note of that. An example of this class is fire. Ang fire class, meron siyang color blue, color red. No? So mapansin natin na pag color red siya, meaning lesser na ang iyahang energy class. Kasi most of the color carries also an energy. So we will discuss that later. So let's compare sa which one has a greater wavelength and lesser wavelength. Okay, between yellow and purple, which one has a longer wavelength?
Yellow.
Very good. Okay, between the blue and red, which one has a longer wavelength?
Red po.
Red.
Okay. So take note of that na red has longest wavelength and then purple has shortest wavelength. In terms of frequency, the red has lesser frequency. The violet has greater frequencies. So in this table, we can see that red, ang mga wavelength niya is 620 to 750 nanometer nm. Okay? Whereas ang violet, the exact wavelength of purple or violet is 380 to 445. So, sa wavelength pa lang, makikita natin na greater talaga ang wavelength dito banda sa taas compared to bottom. Okay? In terms of frequency naman, usually ang nasa top, it's the opposite of the wavelength. So kung sino yung mas mataas ng greater na wavelength, mas lesser ang iyang frequency, kabaliktaran. They are inversely proportional to each other. Okay, so take note that the colors of light are arranged. So bakit nasa top ang red? This is because they are arranged according to the, so the arrangement is from least bent to most bent. So ang red, bakit nasa top siya? This is because red is the least bent. Kasi ang tendency niyan class, balikan natin, pag mag-refract siya, mag-refract ang example, meron dito source of light, is ipadaan mo sa prism. You know what's a prism? Prism is, parang siyang, a glass, na pag strike mo doon yung light, all the colors of light will disperse or separate. So from white light, kung idadaan siya sa isang prism, lahat ng colors niya are mag-disperse. An example nito class ng dispersion is the rainbow, for example. Okay, saan doon ang prism pag mayroon rainbow class? The prism is the water droplets. Okay? So, pag mag-strike ngayon ang light from the sun to the water droplets, ang tendency class is the color of light will disperse. Kaya ma-form ang rainbow. Okay? And the arrangement should be sa top niya, red. Roy G. Biv. So, the best example of dispersion is the formation of the rainbow. So, bago siya ma-disperse, kailangan talaga magdaan ang light sa prism. Kung walang prism, hindi yan ma-disperse ang colors of light. Ganun din mapansin natin pag kahit na ang glass, matamaan lang yan siya ng light or any light, like sa flashlight ba kaya or anything, mapansin mo na may parang nag-form na rainbow. This is what we call as dispersion. It's because the light passes through a prism. And once it passes through a prism, the colors of this light will disperse, will separate. Okay, makikita natin. Okay, so balikan natin na ang red, nasa top yan siya because red has a lesser index of refraction. Least ang pag-bend niya, hindi masyado siyang nag-bend. Unlike the purple, the violet class, kung mag-bend siya masyado, meaning nasa bottom siya. Pag hindi siya masyadong nag-bend, nasa top siya. That is why red is called as the least bend. And the purple or the violet is the most bend. And take note, the arrangement is according to the index of refraction. So kung titingnan natin when we use the prism ground glass, ito ang index of refraction niya. So 1.512, 512. So ang index of refraction niya, kung i-compare natin, lesser compared to purple. Or violet. So pag least ang index of refraction niya, usually nasa top siya. Okay, pag greater ang index of refraction niya, nasa bottom siya. Okay. So ito, bakit may mga colors ang object? So when light hits an object, the color we see is the specific wavelength reflected in an object. So for example, may apple, it's color red. So what does it mean? Color red lang, out of 7 colors, color red lang ang na-reflect back to our eyes. The rest of the colors are absorbed in an object. So actually, kung ano yung makikita natin na color sa mga object, yun lang na color ang nag-reflect sa eye natin back. Okay? So for example, ang banana, it's color yellow. What does it mean? Only color yellow is reflected into our eyes. The rest of the colors are absorbed in the banana. So color green, like for example, ang mga plant, color green, meaning pag mag-strike ang light dito sa mga plants, since nakikita natin color green, meaning color green lang ang na-reflect. So kaya yun lang ang nakita natin sa mata natin. The rest of the color except, so 7 colors, the rest of the colors except green, lahat sila na-absorb sa object. And only color green is reflected into our eyes. So object that looks red are reflecting red waves only or red color. So the rest of the colors like the orange, yellow, green, blue, okay, so lahat sila na-absorb. Only color red is reflected. So paano kaya pag white color? What does it mean? So object that look white reflects all the colors. So ano bang mga object na color white? Like for example, cloud. Okay, ang ibig sabihin nun, lahat ng colors nag-reflects. Lahat ng color waves nag-reflect. Kaya it looks like it looks white. Pero naman, pag color black, what does it mean? Lahat na absorb. So, ano bang mga object ang color black? Sorry, hair. Mga hairs natin, class. So, anong ibig sabihin noon? Ibig sabihin, the 7 colors of light are all absorbed by the object. walang na-reflect. Pero kung lahat na-reflect, lahat ng 7 colors na-reflect, ano ang color na makikita natin sa object?
White.
Very good. Okay. So, since light is a wave, so meron siyang frequency and wavelength. Okay. So, these are actually the characteristics of light. So, one is the frequency. The symbol for frequency is F. This is the number of times waves crest pass a point in a second. So, the unit is in hertz or Hz. This is named after German physicist Heinrich Hertz in 1857 to 1894. So red has the less frequency but longer wavelength, whereas the violet has more frequency but shorter wavelength. In terms of wavelength, the color violet has the shortest wavelength. Red has the longest wavelength. Thus, we can say that from red to purple or violet, the frequency is increasing. Okay? But the wavelength is decreasing. So what is now the relationship between the wavelength and frequency? The relationship between wavelength and frequency is inversely proportional. This means that wavelength is inversely proportional to frequency. What does it mean? When the wavelength is greater, the frequency is lesser. Meaning the lesser wavelength, the greater frequency. Okay? The greater wavelength, the lesser frequency. So, in terms of frequency, balik na ni Ma'am Ning. Okay, from red to purple, the frequency is increasing but the wavelength is decreasing. How about energy? So, since a light also carries an energy dito na. So, ano ang relationship ng frequency and energy? Actually, they are directly proportional because as the frequency of the color increases, its energy also increases. What does it mean? Okay, so the color na merong higher or greater frequency, they have also greater energy, amount of energy. An example of this is yung flame class. Usually, ang color ng mga flame class sa fire shows the amount of the energy. Napansin natin pag color red na ang flame ng gasol or stove natin class, anong ibig sabihin nun? Paubos na ang fuel mo. Diba? Meaning, pag color red na ang flame ng sa stove natin, what does it mean? Lesser na ang fuel mo or lesser na ang frequency mo. But if the color of the flame is color purple or violet, this means that greater energy. This is because ang color red has a lesser frequency, so lesser energy siya. Whereas ang purple or violet has more or greater frequency and they have also a greater energy. Another example nito is the color of stars. Pag color red siya, it means that lesser na ang iyahang energy. But if the color of the star is violet, meaning greater ang iyahang energy. So para hindi makalimutan, i-associate na ninyo ang color of the flame and color of the stars. So pag color red, we all know that red has a lesser frequency, therefore lesser din ang energy niya. Least energy siya. Ang mga violet, so ang color ng flame na pag violet meaning more energy pa siya. And we all know that purple or violet has a greater frequency. So greater din ang energy niya. So we can say that frequency and energy are directly proportional. The greater the frequency, the greater its energy also. The lesser frequency, the lesser its energy, amount of energy too. Okay, so if we're going to describe the uh, the energy and frequency from red to violet, we can say that as we move from red light to violet light, the energy and frequency are increasing. So they're directly proportional. Okay, so the phenomenon in which light separates its color components is what we call as dispersion. And the greater the reflective index, the greater the bending. So which of the 7 colors bend most? Colors.
Violet po.
Very good. So therefore, ang mga purple or violet has greater index of refraction. Okay, kasi nag-bend siya masyado. So red refract or bend least because they are on the top. And color blue appear in the bottom because they are the color that bend most or bent most. So the bending of colors depends on the amount of refractive index. The greater the refractive index, the more it bends. Okay, next. Refraction. So refraction is the bending of light when it travels from one medium to another. Take a look at this example. A pencil, for example, class, is placed in a glass with water. Ano kaya ang mapansin natin? Ba? Mapansin natin na parang na broken yung pencil. Actually, this is a result of refraction. This is because light travels from one medium to another. Ang first medium dito is yung air. And then, the light passes through the water. So, from air to water, there are 2 media. So, meaning the light travels in 2 media. From air to water. So, kaya mapansin natin na parang broken ang pencil because light refracts. Yun ang reason bakit broken pencil ang tingin natin. Ganon din ang mapansin natin sa kamay natin pag ano natin sa mga water. Parang naglaki, no? Di ba? Or mag-walk tayo, for example, sa mga pool. Mapansin natin na ang feet natin nagtambok. Okay? This is because light refracts. Light travels from different media, from air tapos to water. So yan ang sinasabi ni ma'am na there is what we call as the bending of light. This is what we call as refraction. Okay. So according to the Snell's law, this is the law of refraction, that N stands for the refractive index of medium 1. So N stands for refractive index. Then 1 means medium 1. So kanina sa example natin dito sa water, pencil in a water, ang medium 1 is air. Tapos sa bottom niya, that's the medium 2. So kung titingnan natin dito sa law of refraction or Snell's law, N1 is the index of refraction of medium 1 times sin, S-I-N, angle 1. Okay? Tapos is equal to the index of refraction of medium 2 sin angle 2. So meaning this is the angle of refraction. So actually this is angle. Ito na symbol, these are angle. So take note of this equation kasi mamaya gagamitin natin yan for the problem solving. So i-point na natin saan ba yung N1. Okay? Ang N1 is the first medium. N1 stands for index of refraction, N1. So, dito naman banda, let us see this is the glass. So, first medium is air, and then second medium is the glass. So, ang N1 is the index of refraction of air or medium 1. Dito naman sa baba is the index of refraction of medium 2 or glass. So which one is the angle of refraction? Okay, nandito yung angle. Itong angle nito from the normal line going to this arrow, this is what we call as the angle of refraction. Ito naman na angle is what we call a incident angle or angle of incident. Okay? So, balikan natin ang Snell's law. Actually, okay, etong angle 1 is the angle of incident. Ito naman na symbol na angle, this is the angle 2 or the angle of refraction. So, paano tayo mag-solve nito? Okay? So, mamaya, mag-solving tayo. I-show lang muna ni ma'am. So, for example, this one, two media. First media is, nauna pala siya nag-travel sa, okay. So, air to glass. Ano yung napansin natin? Let us see, this is the light. So, sa air, medyo continue lang siya class, ang travel ng light. Pero pag mag-pass through na siya ng another medium, which is glass, what happened is it refract. Hindi siya nag-continue past ang travel niya. But it reflects. So, refract. Okay? So, ang tawag dito na angle is from normal line to the ray of light is what we call as the angle of incident. And the angle from the normal line to the refracted light is what we call as the angle of refraction. So when light travels from less dense material to more dense, it moves towards the normal line. So kung mag-pass through ang light, kung mag-travels ang light from less dense, okay? So usually ang ano niya mag-move towards the normal line. So take a look at this another example. Okay. So from more dense, let us say ang glass, usually ang glass is more dense to less dense, and then the less dense is air. So pag mag-travel siya from glass to air, ang tendency niya, ang pag-refract niya is away from this line. This is the normal line. So when light travels from more dense material to a less dense, it moves away from the normal. So ang pag-refract niya papunta doon, away from the normal line. Whereas kanina, pag mag-travel ang light from less dense, ang less dense dito is the air, and then the more dense is the glass. It will move towards. So, papalapit siya sa normal line, ang pag-refract niya. Whereas, dito, from more dense to lesser dense, ang mangyari sa refraction niya is away, palayo sa normal line. This is how light acts or refracts. It depends on the density of the material. Okay, let's start solving this problem. So let us say a ray of light strikes the water of lingering gulf at an angle of 40 degrees. So compute for the angle of refraction. If the index of refraction of seawater is 1.33. Sige natin, 1.333. Okay. So given, ang first given sa problem is 40. Ano tong 40? Okay, i-draw natin yan sa class. Dito ang 40. This is the angle of incident or theta 1, angle 1. What is asked now is the angle 2. the angle of refraction. Balikan natin ang problem. Compute the angle of refraction. So you are asked to get the amount of angle of refraction here. The given is the angle of incident, 40 degrees. Now, which one is the N1? Okay, the N1 is air. So, since it is a seawater, kasi Lingayen Gulf, di ba? So, ang first na medium na dadaanan ng light is the air. And take note, medium 1 has an index of refraction. Basta ang light mag-travel sa air, usually ito yung index of refraction niya, 1.000293. Okay, tatlo lang ito, sorry. Sulahan si ma'am. Okay, so ito yung index of refraction niya, given, N1. Okay, how about ang N2, given ba? Okay, nasa problem, nakasulat dito na index of refraction of seawater. Okay, meaning, itong medium 2, after siya nag-pass through sa air, pumunta siya ngayon, nag-travel na naman ang light sa seawater. That's the medium 2. And the index of refraction of medium 2 is 1.333. That is given in the problem. So what is asked? What is asked is the angle of refraction. Ito. Okay. Based on the... Okay. Sige, ito. Kalimutan ni Ma'am lagyan ng bar dito. Dito. Wala gihapon bar. Okay, sige lang. Imagine natin na lagyan natin ito. Para hindi kayo malito. So, here. Okay. So, meron dito. Yan. Okay, so ganyan. So, paano naging ganyan ang equation niya? So, n given, n1 given, n theta 1, sin theta 1 given, 40. n2 given. So, ang nawawala is sin theta 2. So, you're going to write sin theta 2 here. And then copy this n1 sin theta 1 as numerator. And then n2 will become the denominator. Okay? After that, substitute. The value of n1 is 1.00293. Then the value of an angle here, angle 2, is 40 degree. 40 degrees. And then the value of N2 is 1.333 here. Ngayon, isolve natin ito. Paano gawin? So, get your scientific calculator now. First gawin mo is click mo ang sine. Followed by 40. 40 lang. Sine 40. Times 1.00293. Walang mag-equals ha. Dire-diretso lang. Sine 40 times 1.00293 divided by 1.33. Tapos plus, meron pa kasing sine dito. So, ang gagawin natin, itong sine, ilalagay natin dito over sa result na to. So, magiging 1 over sine. So, paano ba natin yan i-press sa calculator ang 1 over sine? That is shift tapos sine. Kung meron ka ng answer, pindutin mo ang shift. Tapos sine. Ano ang lumabas na answer? Pwede natin ulitin kung kasi kasagaran syntax error, no. Okay, ulitin natin. Pindutin ang sign, then 40 times 1.00293, then divided by 1.33. Answer. Pindutin ang equals. After mapindot ang equals, shift sign. Okay, supposed to be your answer is 28.9. When you round off that one to whole number to get the degrees, it's 29. So therefore, the angle of refraction is 29 degrees, which is lesser than the angle of incident. Okay? Yan yung sinasabi dito na the angle of incident is greater than the angle of refraction. So the angle of incident here is 40, while the angle of refraction is 29 degrees. Okay. So, i-change natin itong angle of incident into 23. Okay, gawin natin itong 23. Same lang ang mga media. Medium 1, air, which has an index of refraction of 1.00293. And then medium 2 is seawater. And then the index of refraction 2 is 1.333. What do you think is the value for angle of refraction? So, ang gawin mo, pindutin ang sign, 23 times 1.00293 divided by 1.333. Then shift sign. Kung error class, you can repeat it again. Sign 40, sign 23. Pwede mong ulitin. Walang mawala sa'yo. Usually, pag namali mo pindot, mag-error siya class. The answer is 17.1. Okay. So this becomes 23. So this one is 23. And the answer is 17.1. Or, we're going to round off that one to whole number, 17 or 18. The answer is
17.
degrees. And that's the angle of refraction. This is how to solve the angle of refraction. Okay. Okay, so balikan natin yung gusto nyo pang malaman na, okay, ito. So, properties. So, actually, there are, we will discuss only one up to pang higher na to. Okay. So, we'll limit only to the refraction, reflection, and dispersion. Refraction, the bending of light. So, when the light passes through from one medium to another, it will bend. It will refract. Reflection, yung pag-appear ng mga colors sa object is an example of reflection of light. Na pag color yellow, it means only yellow is reflected into our eyes or reflected in an object. Nag-bounce back ang color yellow. The rest of the colors are absorbed in the object. That's the bouncing of light. Dispersion, the separation of colors of light, of course, with the presence of prism. So once the light passes to a prism, all the colors of light will separate, will disperse. Okay, so this is how reflection occur. So let us say this is a glass. Some of the light will bounce back. So this is what we call as reflection. Ito yung nangyari sa mga color sa mga object na bounce back. So let us say isang object ito, tapos pag ano niya, nag-bounce back ang color green, so the rest of that are absorbed. Absorb means yung papasok lang siya. Papasok lang siya sa isang object na dinanaanan niya. Transmit naman, meaning it will pass through from one object to and then lalabas na naman yung lights. Usually, mangyari ang transmitted sa mga translucent na mga object like glass, okay, mga windows. Oh, dyan. Dyan na case mag-transmit ang light. Kumbaga, wala siya na-reflect, wala siya nag-bounce back, wala siya na-absorb at lumabas siya, nag-transmit siya. Okay? So, another one. Okay, ito yung example ng transmit. Sa mga transparent, usually sa mga transparent glass, like, not only glass, like for example, cellophane. Oh, yan, transmit ang light, diretso lang. Okay? Pag translucent naman class, ito yung mga ano, mga glass gani na may mga design, yung mga curve ay rough masyado ang glass na yun. Yung parang may mga design pa siya, rough, not smooth ang ano niya. So ang mangyari is ganito. Ganito ang mangyari sa mga light rays niya. Okay? Pag translucent. Pag opaque naman, usually yung mga object like wood, opaque na siya class, it will just absorb. Musulod lang siya diretso ang light sa isang object. Okay? So, as I have said, reflected, yung mag-bounce back, absorb, yung magpasok lang sa ilalim ng isang object, transmit, yung mag-pass through. But it will have a refraction. So, mag-refract siya once mag-transmit. So, that's the end of our lesson this afternoon. Thank you very much for